Okay, so welcome everyone. So this is the first guest lecture from the course we are doing, the Generative AI in Finance for Model Risk Professionals. So we kicked off this course this week, and we had a fascinating discussion in the room with professionals from multiple organizations talking about the challenges they're facing with model risk management and AI risk management, primarily for generative AI models. And we had a 3-hour session, and the discussion continues over the next 3 weeks. And we are going to be, having weekly guest lectures as a part of this course we are doing this summer. And if people who are interested, I'm going to throw in a link. So we are also starting a second cohort by popular demand. So the first cohort has already started last week. It's a little too late to join the first cohort, but the second cohort is enrolling, and I'm getting a lot of people asking questions about what the course is about and what you're going to learn. And it's a 4-module course, like any other Quant University course if you have taken before. There are a lot of labs and in-class discussions. So please feel free to check it out. I'm going to throw a link. And we also have guest lectures as Uday. I'm going to introduce our speaker in a minute. Uday, who is going to be kicking off the guest lecture series. But in the next 3 weeks, we also have guest lectures from Scott Eilhertz from American AG Credit, and then Agus Sugianto, who's going to be coming back and doing a 2-hour workshop, and then Jacob Kosoff from Bank of America is going to be doing the 4th guest lecture as a part of this first cohort. So I hope you are going to get benefit from the experts in the room and their immense knowledge and how they have been thinking about risk management and also various facets of artificial intelligence as we are kind of seeing. And again, as I mentioned in the classroom, there's no way one person or one organization can kind of have expertise in all these areas. So it's a collective aspect of bringing together peers and learning from peers, but also learning from the experts. And I hope you're going to be leveraging this session and the next future sessions to learn from the various experts. So today I would like to welcome Uday Kamath. Uday and I know we have known multiple years. I'm very much a fan of all his work he's been doing and the books and the journal papers and the conferences and all the things he's been doing. So brief introduction to Uday. Uday brings in more than 25 years of experience in artificial intelligence product management. He has a PhD in scalable machine learning, and he has written multiple books: Reinforcement Learning, Large Language Models, Explainable AI, Transformers for Machine Learning, Deep Learning for NLP, Speech Recognition, etc., etc. And he serves as the Chief Analytics Officer at Smarsh, wherein leads data science and research in communications AI for regulated industries. So he knows what building software for regulated industry actually is and why you can't get away with a simple prompt. So today he's going to be talking on AI coding agents, the good, bad, and ugly. I saw his presentation over LinkedIn a few weeks ago, and I thought like, hey, Uday, would you want to come and share your immense knowledge with our audience? And he was gracious enough to join us today. So welcome, Uday. Thank you for making time for us.
Thank you. Thanks, Krishna.
Yeah, so if you can share your screen,
Yep.
and yeah, I think we are good to go. Yeah, so we can see your screen. So if you can put it in a presentation mode, we should be able to see it. And protocol for people who are listening in the audience, I'm going to be moderating the session. So if you have any questions, feel free to ask in the Q&A or the chat window. And then later, the last 10 minutes or so, we will devote for Q&A. And I'll bring up those questions. And hopefully we can try and get some questions answered at the end of the session. Okay, cool. Thank you, Uday. Please take it away.
Thanks, Krishna. So I'll start the presentation at very high level. 2 years ago, in whether regulated, unregulated, any industry we are, coding has become one of the most important thing that the AI agents or AI agentic frameworks or AI has been able to accomplish. You had like Cursor, Claude Code now, Copilots, Codex, Devin, Windsurf. The list keeps growing. look at what we measure when we say that these tools work. So on the left side, you have like, we normally think about like, does the code pass? How fast do we ship? How many lines are generated? How many tickets are closed? But on right side, the most important, whether you're putting a regulatory hat or any hat, is can someone read this in 6 months? The whole aspects of responsible AI, trustworthiness, safety, security comes into picture. Does it fit into our architecture? Did the model actually understand the bug? What is the total cost of ownership? And in general, like there are many gaps is what my presentation is about. So I'll start with the good part of it, that is things that are genuinely good. And as you know, prototyping and exploration, the single biggest win in prototyping is the prototyping speed. Idea to working prototype is in minutes now. You can try n number of approaches all parallelly these days, even though you can have to have some token budget, but you can generate ideas, you can prototype at a rapid rocket speed. But the part that does not get enough attention is thinking the partner role. Before I write a single line, I describe what I am trying to build and ask the agent to help me think through the architecture, rubber the debugging that talks back. That does not show up in any of the productivity metric. So one of the things to keep mind is like brainstorming skill, irrespective of what you're doing with AI coding or any of the AI agents, is to have a brainstorming skills. Boilerplate and tests and documentation. As you know, the three categories where agents are unambiguously excellent is scaffolding, project setup, config, CRUD operation, API stubbing, testing, unit testing that Krishna was mentioning, fixtures, edge case enumeration, mock setup, documentation, doc strings, readme, change log, PR description. All of these scaffolding is like the strength of AI. So we need to make sure that the things that are tedious but not hard, well-established patterns, immediate feedback, this combination is where agents really excel. Migration, refactoring, and why these work. Migration at scale, framework version bumps, API deprecations, cleanup, code base wide renames, days of grunt work can be done in like hours. Why do all these tasks work well? Four properties: low ambiguity, bounded scope, fast feedback, high pattern density. Keep these four in mind. They will matter when we talk about where things break down. The good is practice. The ecosystem now is more mature, and people realize that this has become really, really strong. Now, these tools, we have found a permanent place. Like I'm sure every one of you has been using AI in some form. As I said, like some people use Cursor, some people use Codex, some people use Claude. No matter what, I am sure that you are using it for all the right purposes, like whether you are doing it for scaffolding, testing, documentation, no matter what, I'm sure you are using it. Now I wanted to go a level deeper. This is where the code that passes every test but fails on reviews. What are some of the bad things we see? And here it is just not at the AI coding agents, but in general, we need to put the skeptic's hat when we have to look at any of the things that AI generates. So I'm sure that many of you are software engineers, and you know that AI code generation or coding is more about reading the code than writing or generating the code. The AI coding agents optimize for writing it. Understanding the code, understanding it from the experienced engineer is the vital part. Now, here is like what I want to bring to you is the most important benchmark that you should, at least some of the important takeaways from this particular lecture are some of these important metrics, some of these important benchmarks, and the thought behind that. Slop Code Bench from Orlansky and the colleagues. They generated 20 problems, 93 checkpoints, 11 models were compared. Here is what it makes it different. Most benchmarks are single shot. Slop Code Bench is iterative. At checkpoint 1, the agent implements things from scratch. At checkpoint 2, it extends its own prior code and it goes up to 8 checkpoints. The critical design choice, the agent's own code carries forward. No gold standard reference replaces its work between the turns. If it hardcodes something at checkpoint 1, it pays at checkpoint 3 or 4. Bad architecture compounds. Code flow bench gives clean code between turns. SWE bench is one shot. Slop code bench chains agent outputs and measures quality at every step. Now, this is the most important thing in my view, that putting the skeptic hat, having benchmarks which not only check things from academic perspective, but something that is on real world, simulating the real world is the most important benchmark in my view. Again, instead of measuring the normal metrics of like uh, the tickets or other outcomes, can we measure something which is bit negative or something which gives you insight is another important aspect. So here there are two metrics. Metric 1 is structural erosion. This paper introduces two metrics in addition to this particular benchmark. And structural erosion is at very high level, is complexity spreading evenly or piling into few God functions. For each function, compute its complexity mass, cyclomatic complexity times the square root of source code lines and stuff like that. A small linear helper to kind of a low mass thing. And step 2 is erosion is the fraction of total mass in functions above a threshold of 10. If erosion is 0, every function is clean. For instance, if erosion is 0.8, 80% of your complexity is jammed into handful of these massive functions and so on. The paper has a function that grows to cyclomatic complexity 285 over 8 checkpoints. Imagine that as 285 decision branches, one function, and still it passes all the tests. But there is a structural erosion at that point. The another method, which is kind of like what all AI slop generates, is verbosity. Count lines flagged by AST grep rules or detected as duplicated codes and stuff like that, divided by total number of lines. That is the fraction of your code base, which is kind of redundant. It gives you a redundancy matrix. So basically, you are capturing two important attributes of an agent in terms of complexity and in terms of redundancy. So having benchmark which is simulated to capture real life and having metrics that is indicator of what AI agent should be actually tested for gives a very good insight into what people should be measuring. And here is like important key findings. What it finds is the headlines: 0% of problems are solved end to end by any agent. 80% of trajectories show rising erosion. Nearly 90% show rising verbosity. Agent code is 2.2 times more verbose than human repos. The last bullet: prompt intervention shifts the intercept, not the slope. You can tell the agent to write cleaner code, it starts cleaner, but the degradation rate is same. The slopes are parallel. Prompting does not solve the compounding problem. So these are important takeaways that this paper gives us from the AI coding perspective, but at meta level, it tells us how AI should be actually seen, validated, tested, and how do you actually put that skeptical hat. I will share with Krishna after this. Or you visit my Substack, I have reproduced some of these in my own GitHub repository. I have created, like, if there are 3 prompt strategies, how would I measure these particular metrics and more, and actually create different scenarios of simple solution planning, and how do you do anti-slop and actually see the delta between the strategies. So this is more to understand what the paper does, but actually do a real world agentic validation so that you can play with it and understand how each of these systems work. And again, there is like a lot of insights into what my uh, paper or my reproduction does. And there are insights into like how by using anti-slop, by using right prompts, we can have better cut in terms of cost. How do we go from like slop generation to bit more token friendly yet cleaner implementation and stuff like that. Now, now we went from like the good part to the bad part. And in the bad part, I was talking about what we should be doing in terms of benchmarks, metrics, real world, and stuff like that. And now I wanted to go a bit more extreme. That is, what are some even uglier part that we are always seeing or we will see with some of this? Now, as every one of us know, maintenance is 60 to 80% of the cost. 60 to 80% of total software cost is not actually building it. It is in maintaining it. Requirements evolve, teams change. Decision in sprint 3 has consequences in sprint 11. When we evaluate an agent on a single fix, we are measuring something that does not exist in production, a static self-contained problem with no history and no future. And this is where the SWECI benchmark comes into picture. Now, this SWCI is from Sun Yat-sen University and Alibaba. What it has is 100 tasks comparing 18 models. Each task spans 233 days of real development, 77 commits consecutively done, and the agent gets a budget of 20 iteration. The agent starts with the base code base and gets the Oracle test suite. Tests that pass against the target but fail against the current state. No human issue description, just the CI output. The dual agent architecture here, an architect agent takes stack traces and converts them into structural requirement, and a programmer agent reads those and modifies the code. They cycle in an iterative tandem, and they cycle until the convergence or the budget exhaustion, that is in terms of iterations, happen. Now, here there is an important aspect that we need to measure the trajectory. Why pass rate is not enough. A fast brittle fix at iteration 3 looks great on snapshot. If it breaks things in iteration later, like 5, 8, 12, pass rate never captures the cost. Evo score works in 2 steps. First, at each iteration, it computes a normalized change. Positive means tests fixed, negative means tests broken, regressions count against you. Second, it aggregates with future weighting parameter. Later iterations matter more than earlier. This rewards agents whose code stays healthy and robust over time. Zero regression rate, that is below 0.25 for most models. And it is really interesting that in 3 out of 4 tasks, the model broke something already worked. Only Claude Opus 4.5 and 4.6 exceeded 0.5. They fix what is in front of them and break what is behind them. Now, I actually did, again, like I'll share it with Krishna, I implemented this Evo score and tried to use the same benchmark in my study. And I have written the whole Substack article and the code that goes with that. And there is an interesting aspect that I came across. The compounding effect. Translating research into what it looks like on ground, month 1, agent can close 50% more ticket. We normally celebrate in terms of velocity and everything. Few months later, the debugging time increases. People say code base has got complex and nobody connects to the agent code. And later, as we see, when the new member comes in, the things have been generated and have gone through reasonable complexity and has become complex to the level that it is incoherent. The gain in generation is offset by loss in maintenance. This is, to me, like one of the most important aspect of any generative AI thing, whether from coding perspective or any generative AI, where we are using it as a tool or for generating things that we care about. Now, debugging is another important aspect. Debugging is about causal understanding, tracing execution paths, understanding the state, reasoning, whether whatever reasoning model you use, understanding what it is doing is key, whether it says that it is using chain of thought, etc., etc., in terms of tracing what actually happened. And if you put the regulatory hat on this, most regulatory system who are using generative AI or reasoning models have to have reasoning traces, and you need to use these reasoning traces as evidences. Now, there is an important paper about reasoning theater, and this is where things are, to me, are very, very important from regulatory perspective. On left side, you will see that most reasoning models follow step-by-step analysis. They trade off evaluation. The agent says that it traced the X null pointer or whatever it was doing. It shows that it is actually understanding. What it may be is it is post hoc rationalization. The model patterns matched null pointer constructor to add the guarded clause. The reasoning trace is a narrative applied after the prediction rather than before the prediction. Developers use chain of thought as proxy for reliability. The reasoning theater that many of these models, as the paper goes through, breaks that heuristic. You cannot trust the explanation anymore because it may not be actually going through the process it says that it was going through. And that is why you have to ensure that there has to be some form of defenses. Now, in my view, when you are building AI coding agents or any form of AI systems, you need to have different forms of defenses. That is like having things like what I call the first level of defense, where you have to go beyond functional test. As I showed, like track metrics that are things like erosion, verbosity, not convenient metrics like pass rates or lines of code. Treat AI PRs with same rigor you apply to a junior developer's code. Even more, I would say. Second is maintenance-aware development. Track trajectory metrics, not just snapshot. Monitor zero regression rate in CI. Human designs the architecture, agent fills in the implementation. Build a culture where periodic rewrites are preferred over perpetual patching. The research shows that extended eroded code always makes it worse. Third, as I keep saying, healthy skepticism. Verify outputs independently. Chain of thought is a conversation aid. It is not a proof. The statement that agent explained why this worked is not same as I understand why this worked. Test the hypothesis. Do not trust the narrative. And that to me are like simple 3 layers of defense, whether you are using for AI coding task or for using any of the agentic AI in terms of generating things that matter to you. So at the end, I just want to say that use the agents, whether for coding or for any of these things, but be the senior engineer, be that senior human in the loop. And even when the agent sounds more confident, just make sure that you have a skeptic hat. You understand what it is doing. You understand the narrative and you understand the reasoning traces. So I will share uh, the notebooks, the code, and all my writing with Krishna so that you can also use this hands-on and understand these metrics, how to use that in real world and kind of like build your own system. Thanks.
Well, thanks for that. Thanks for the amazing lecture. I know there are a lot of details in the slide deck, so I'd love to kind of get my hands on both your article and also your slide deck. Couple of questions, and I'll start off. If there's any questions in the audience, please type it in so I can kind of discuss that with Uday. So first question, Uday. I mean, obviously the field is evolving. Many of these terminologies are not
Yeah.
kind of, set in stone, if you will. Now, some of the things which are kind of also becoming standard practice is this notion of specification
Yep.
driven development, right? So,
Yeah.
spec-driven development is
Yeah.
becoming something
Yeah.
wherein instead of you trying to educate an agent on what you want to do, you specify the parameters so that the requirements are generated in a more formal way. And you can, I mean, technically you are kind of, building out how humans would do development. Humans would never start with coding.
Yep.
You will basically build out the requirements, you
Yep.
will build out the functional requirements, the technical requirements,
Yep.
and the test harnesses, and then you build it out, right?
Yep.
So how, in your experience, like, how do you kind of accomplish that leveraging coding agents in the context of, do you build skill files and provide it to agents saying that, you got to do this, or what is the best practice you've been advocating?
So that's an amazing question, and like it touches many various aspects. Like, and you are right. Like every month or every week, things change. When Andre Karpathy came up with like the wiki concept, it has taken things by really storm, and many people are actually using these wiki concept of like. Uh, how LLMs and agents can modify the wiki, similar to like the Wikipedia, and has like that overlaps with Speckit. It has the overlaps with uh, the many other design or areas where they overlap, but the system is evolving, and you have to actually see for your institution, for your problem, what works. Like if you take Andre Karpathy's idea and work for, say, NASA in a very regulated way, it may or may not work. Whereas a small two people development can actually use agentic skills, as you mentioned, break down it into like the markdowns, have chain of skills that are connected, because it is very easy to understand the purpose, to see what the input output steps are, write down the procedure, as you said, like whether through specification and stuff like that. So there are different ways, and it, in my view, you have to use some of it, test what works for you, and the combination is what I have found to be useful in my view.
Okay. Thanks for that. I mean, it's something, when we work with our clients and when we teach these topics, we formalize the process.
Yeah.
That way, you not only audit the outcomes of the agents,
Yeah.
but also you audit the process, because, in some ways, if you can't replicate the process, I mean, you can't replicate the agent's behavior, but you can replicate the process because you want to standardize some of these aspects. And another thing I wanted to ask you was, you mentioned this notion of AI slop, when a coding agent which builds it out generates more code than necessary. I mean, I'm kind of, let me play devil's advocate in here a little bit. I mean, when I used to give assignments to students back in the day, they would generate code which was, I would say, semi-functional, because it would work in only specific use cases. And, many a times it would be, I mean, the students writing, graduate students writing code, so it's not production friendly. However, we would always kind of use that as a teaching moment to focus on unit testing, exhaustive testing on the API, making sure that you're doing input validation, output validation, building out the pipelines and understanding the logging aspects, treating it as, a way in which you could standardize these workflows rather than you treating it as a one-time effort, right? Now, in some ways, I am actually enjoying the innovations in technology because maybe I am a more experienced spec writer, if you will,
Yeah.
because
Yep.
I can specify, my unit tests. I can specify saying, create the test harness
Yeah.
and then write the code against the harness.
Yeah.
And I basically ensure that I get what I am actually able to validate once the code has been developed, right? I also do a lot of synthetic data generation for test cases to make sure that I understand what the expectations are with respect to input-output validation. I mean, in the financial services world wherein we typically work with, we already have input data. We already have, some amount of ground truth for certain use cases. So it becomes a little more, the champion challenger kind of an approach wherein I already have like a simple model which does XYZ, let's say a simple regression model which does something. So if I'm asking a coding agent to build a more sophisticated model, and then I could do a apples to oranges comparison saying, okay, this was what I got, this is what. So in some ways, I actually expect that the coding agent should be generating more code than someone who is kind of building out from scratch. And I also want to try and use iterative development wherein I can put in my requirements, ensure that, oh, you missed out this, oh, you did not consider this. So that's kind of the human in the loop. In addition to that, I also want to see how close can I get through production rather than treating it as a prototyping effort and then redoing the whole thing from scratch. So in some ways, I expect more code to be generated. However, I understand that, like if I do a top-down approach, which is the worst way of writing code with agentic software,
Yeah.
it's basically, creating like what you see in the demos, like, create a website which can take a credit card and basically, give you a confirmation. And it's a very high level requirement. And now you're expecting an agent to kind of, chunk it down into do a work breakdown structure, build out like the lineage, think which task could be done in parallel, think which task should be like linearized, and build out the whole thing. So I think, in some ways, uh, I'm kind of probably putting some of my thoughts into the question itself.
Yep.
My expectation is the more or the better the specification is, the code which is generated actually reflects my thought process rather than the other way around, wherein if I give it very small amount of information, it probably will make up a lot of stuff and kind of create things which I didn't even expect. So isn't that how do you kind of address this conundrum that you don't want it to generate a lot of code, you want to kind of just enough for doing what it needs to be done, but I also want to write test cases. I mean, like I come from the MathWorks world, right? Like when I used to write code in MATLAB, the first example for a federal organization we were training, we would ask them to implement compute a mean of this particular vector, and they would write a 4-line piece of the code, and then we would open up the actual MATLAB mean function and show that it's like close to 200 lines of code. And it's because you're doing input validation. What in case you pass a matrix? What in case you pass a vector? What in case you pass a vector with text in it? So you test out all these cases and make sure that it actually does its job, right? So how do we kind of address this conundrum?
I think you answered it yourself while going through the whole thing. Is you have to have human in the loop. It can't be like top down. It has to be iterative. It has to be spec driven. It has to be requirements where you have to be very, very specific. Whether you do it through wiki, you make it iterative through loops, whether you use iterative skills, however you do it in terms of the agentic form, you have to actually think like that senior software engineer, as you mentioned, break it down and make everything verifiable, make everything uh, every the scope of it should be very well known, and it things should be verifiable. That is, like, you need to have like code driven, test driven, and all that you mentioned. So it is a process, as you said. Like, it is not like a one shot thing. It is a process, and nailing that process in terms of tools, in terms of techniques, in terms of like the iterations, in terms of where that senior human has to play a role, what kind of role he has to play, how do you put yourself as like a devil's advocate and validate things. You need to have this built in your process. And in that case, yeah, it will generate code, but more or less that code would be much better than like what a junior software, or like, as you mentioned, would have written. And going towards production would be much easier if you follow all of these steps.
Hmm. Okay. So, I mean, many of the people in this audience, Uday, are in the financial services world, wherein in this regulated industry, we have this notion of, I mean, you mentioned three lines of defense, but we use the three lines of defense in a very specific way in the
Yeah,
financial services world, right? Like,
yeah.
you have, the first line of defense
Second
is
line of defense
developers.
and third line. Yeah,
Right, right. And
yeah,
second line of defense, most of the audience are in the second line, which is the model risk management. So
yeah.
wherein you're taking what the developers wrote and you're kind of validating and verifying all the aspects. Now, do you do something similar in the context of building out code? Because in the class we had on Tuesday, I think someone was asking, do you validate the agent or do you validate the outcomes of the agent?
So
Right?
fantastic. Like, as you know, like I work for Smarsh, and like the AI that we use is used in all of like 20, top 20 banks in the world for doing compliances, for regulatory compliance, in mostly in surveillance and supervision, where we have to monitor things for market abuse, to all kinds of like market manipulation and things like that. So it's a very, very regulatory world. And in that, when we build agents who are doing the work of humans, or doing assistant work as an assistant, and whether they are using coding agents or the skills framework, we have to provide various things that are required, as you know, from the regulatory standpoint. Like, what are the reasoning traces? Can I capture actual things? Has the reasoning trace match the outcome? Is the reasoning trace accurate? Is the reasoning steps following the actual process? What is the statistic of it? So it is both measuring the outcome, understanding the steps, understanding a level deeper in terms of reasoning traces, measuring that, as well as like correlating it to the outcome, and having that whole picture in a regulated world.
Yeah. And who does that? Is the role of a human or do you write another agent to do that?
So right now that so it's a turtle on a turtle. So right now we have written an agent to do that, but humans actually verify it. So agents capture. There is a coordinating agent. There is a kind of like auditing agent and stuff like that, which captures this, and humans actually verify it. So it reduces the load on humans, but humans are needed to actually not only verify the outcomes, but even the details to match the outcomes.
Yeah, and I sometimes joke with this, right? In this context of, AI, I mean, billions of parameters, it has read through the whole internet. No human can potentially do it. And it has like all the superpowers to access tools, access the web, read through entire sets of documentation. confirm the whole thing and build out things. But now we are kind of delegating the responsibility of verifying this super agent's work. I mean, I consider myself as a minion
Uh,
compared to what an agent could do with the tools it has. And I own the risk. I am responsible to
yep.
sign off, right? So it's a very asymmetric world. I mean, frankly, I don't want to be in that job wherein, an agent can generate like hundreds of thousands of lines of code and basically says, I've done my due diligence and here's a report. And you mentioned a bunch of metrics. I mean, some of those metrics are really new to me. Frankly, I'm not
Yeah.
going to, claim that, I know
Yeah.
any of that. But, holistically, if I, look at a metric, overall metric and say, hey, I'm comfortable with 95%
Yeah.
of what it is. And now I'm expected to sign off saying, okay, this is good enough. I like it. So are we kind of punting the whole thing to, uh, I mean, we're not making people, scapegoats in here, but the goal is like, I should be able to do something tractable, right?
Yep.
And I'm kind of seeing not only AI slop, I'm seeing metric slop.
Yeah.
Every graduate student is like coming up with their own metric
Uh,
and saying this is the metric you should be using to look at the thing. And I'm confused, like as a pragmatic, professional who is having a fiduciary responsibility, wanting to make sure that whatever we are doing for productivity is not something we are just doing for productivity's sake, but it's something which is usable. How are you guys addressing the conundrum? I mean, like, are you taking? I mean, like, if they come to you saying that you take this whole code base we built, verify and sign off, saying it works, are you taking that responsibility, or is your agentic software taking that responsibility, or are you going to put in a lot of boilerplate, small print at the end saying whatever we say is our qualified opinion. We are not responsible for any of the outcomes of this particular thing, and just leave it at that.
No, I mean, like these are kind of like complex questions, as you said. Like there is no single answer, right? Like if you go to Claude Agentic or even Chat GPT or any of that, they always have this fine line saying that Claude can make mistakes or ChatGPT can make mistakes, right? Like that is the most important point, that whether hallucination or like all of that is inbuilt in these generative software and generative AI, and they will generate whether through slop or whether through hallucination, wrong information. And the the buck stops at the people, right? Like as you rightly said, the question is what metrics matter, what are you validating, what is your process. And that is where MRM will become more and more complex in my view, where MRM is just not about looking at the outcomes and having some form of explainability, is actually guarding against each of this and having reasoning, having kind of like deeper dive downs in each of these areas, so that like MRM is not only in terms of like we have governed in this responsible AI, but responsible AI itself has changed a lot because of this. And the metrics and new metrics, new form of validations, new outcomes, new correlations, all have to become part of that.
Yeah, yeah. So there's one question, I don't want to, ask. I have like 100 questions. I probably
Uh,
can sit with you for the next few days just asking
yeah.
questions. But also like thinking about questions, right? Because these are the kinds of problems we're dealing with on a daily basis. So there's a question from Walter. So Walter, you've been doing a lot of homework. Walter is taking this course, and he's kind of bringing up some of the very interesting thoughts. And this is actually a question I wanted to ask, but I'm glad that Walter is asking. So could you please revisit the comments you made regarding the value of chain of thought as evidence? How is this packaged? Because is it mostly the trails, or is it most of the thinking process? You mentioned about looking at the traces of reasoning. So, do you have any thoughts on how you formally package it as an evidence package?
So I don't have an answer, simple answer that can go with this. Uh, Chain of thought, again, like I will share the paper. I think someone asked what the paper is. There is a paper you can Google about reasoning theater, and it actually puts probes inside the both the encoder and decoder side of LLMs. In terms of GPT based are all decoder causal decoders, and it shows that before it generates the reason out of it, from the layered perspective, it already knows the answer. So the point I was trying to make is chain of thought may be evidence of like how it actually got it, or
Mm-hmm.
it can be a narrative that is post after the answer, just to fit in the answer. It is giving you the it is giving you that kind of chain of thought or a reasoning thing. So the paper actually gives you a very good way of actually going diving deeper and actually validating that reasoning chain of thought, but giving that uh, uh, putting that to the side. What we have done, or many places I have seen, is in your agentic world, whether AI coding agent or any other agent, you have like these shared primitives or skill in your skills. For each particular agent, you need to capture exactly the reasoning traces and explicitly capture the, if you have written n procedure or n things in your skills, you need to break down each particular elements of that, write it exactly how it reached to that and why it did in your shared primitive. And we actually keep all of that in JSON format so that we can revisit and get a higher level view of that.
Yeah. So, I mean, like some of the things I do is obviously, think step by step, kind of,
Yeah,
make
yeah,
sure that,
yeah,
you kind of,
yeah,
put that in your process. I also use mixture of experts, basically kind of having multiple perspectives and then have, different approaches and then say, okay, don't come with like one approach, come with like five different approaches, wearing different hats, and then come up with, then consolidate that.
yeah,
And then I try to maybe even incorporate an LLM as a judge
yep,
in an independent thread to kind of,
yep,
say, okay, now poke holes,
yep,
see if there is anything. I mean, these are all not bulletproof methods, but I use this notion of, in risk management, the thing is like, the cheese holes, right? Like, you're
yep,
for the analogy, right? Like if there is like a block of cheese with multiple holes,
yep,
right? So if you slice them and then you scramble them and you put them together and you pass in light, the holes are blocked because you are trying to create multiple defenses to the problem. And the hope is like you are trying to make it bulletproof to show the due diligence that you have thought through what could potentially go wrong instead of taking a single shot approach. But again, like those are not obviously, they're all heuristics. They're not
yep,
provable.
yep.
But again, at this point in time, I don't know. I wish I knew, that I could potentially, call in another model which probably does all these things. And I don't even mind paying, OpenAI or Cloud to say, okay, you pass it to this reasoning model and you take care of all the things which I intend to do with respect to prompts and tokens. But anyways, but that's something like, we have been experimenting on our own. I know it's a little bit over 1 o'clock, Uday.
Yeah.
I know people still have questions, and I know they can reach you on LinkedIn. But thank you for sharing your immense thought and your process. So, is there another book in the works you can reveal?
Yeah, yeah. There is a reinforcement learning book coming out somewhere
Okay.
in September.
Okay. So we look forward to it, and
Yeah,
we'll invite you back in one of the future sessions.
Yeah.
And thank you for sharing your knowledge. And please share the slides, and I'll share
Yeah,
it with the audience.
Yeah, I'll share my
So,
slides and like some of the related papers and stuff like that over email. And you can.
awesome, awesome. Yeah. Thank you so much. And participants, thank you again. So
Thank you
next week
again.
we have
Thanks for great questions.
yeah, thanks, Uday. So next week we have Scott Ellerts from American Accredit. I would really appreciate if you come into this next session and see from a practitioner's perspective, because Scott has a PhD in theoretical physics. So and he took my course a bunch of years ago on AI risk management, but he was a discoverer, and then for a little bit he actually played the role of a fractional MRM lead for another organization. And there they were asking a lot of pragmatic questions about how to do MRM for AI-based models. So he has some, learning from the trenches kind of a story on how they accomplished it. So you'll get some, insights on how they were able to accomplish it in the next week's session. So next week, again, the guest lecture will be on Thursday at 12 o'clock. So we'll see you then. Thanks again, Uday. So